Okay, good morning, everyone, and welcome to today's webinar, Connecting Your Kids. My name is Lotta Pirttimaa. I'm the project officer at Ocean Energy Europe, who coordinates ETIP Ocean, the European technology and innovation platform for ocean energy that aims at promoting the sector on its way to industrial rollout by sharing knowledge through these webinars, for example, and gathering the sector together and also giving advice to the European Commission. ETIP Ocean is coordinated by OEE with the support of Technalia, University of Edinburgh, and Wayback Offshore Renewables. And today our webinar is all about connections. Reliable connection systems are very important for ocean energy devices because they ensure that constant electricity transfer and quick connections for electrical cables and mooring lines also reduce the duration, cost, and the risk of offshore operations. And so far, the ocean energy sector has relied quite a lot on developments in other sectors, such as offshore wind or oil and gas. But as the sector progresses, it's really important to develop solutions that serve the specific needs of ocean energy devices. So in this webinar, we have 3 experts discussing their solutions for innovative connectors and how they can help increase reliability and reduce the LCOE of the whole device. So I'm just going to share my screen and show you the agenda for today. So I also want to say that the slides and this webinar will be available on our website, etipocean.eu, in the events side, so you can check it out there later as well. And before the 3 presentations that we have, I will give the floor to Jose Luis Piate, who is the Offshore Renewable Energy Director at Technalia and the co-author of the Strategic Research and Innovation Agenda, which this webinar is based on. So he will tell more about that to give you a bit of background. So with that, in fact, I will give the floor to Jose Luis. Just a second.
Good morning, everyone. Thank you, Lotta, for the introduction.
Share your screen now.
I will share the screen now. I hope you can see now. Okay, so
yes.
As Lotta said, we are going to make a very short introduction of the supporting document of this series of webinars, which is the Strategic Research and Innovation Agenda for Ocean Energy, before listening the other speakers. The SRA is a reference document for the whole ocean energy sector and gives specific inputs to public funding bodies, including member states, for inspiring research and development goals. For example, we see some inputs from this strategic document included in the drafts of first Horizon Europe calls for ocean energy. The report has not been produced from scratch. It is an update of the previous strategic agenda produced in 2016, and the main driver for this update was reaching ocean energy commercialization. With this purpose, we try to involve as many stakeholders as possible. The SRA was officially launched last year in June and is now a public document. The Strategic Research and Innovation Agenda has been developed in a context where ocean energy can play a crucial role in meeting the European Green Deal objectives and a 100% decarbonized energy system. Different European strategies are behind these objectives, such as for the strategies on offshore renewables, industry or SMEs. One of the more recent one is the offshore strategy produced or published by the European Commission in November. We believe that ocean energy can be the next big thing in energy. The SRA includes a chapter which quantifies the effort on research, technology development, and innovation needed to move forward this sector. 1 billion euros should be mobilized from 2021 to 2025, from which 1/3 would come from private investment. Due to the stage of development of oceanage technologies, 70% of funds should be devoted for demonstration, pre-commercial, and industrial rollouts actions. The SRA includes a number of challenge areas which represent a set of research and development fields that the oceanage sector has identified as most worth of investment during the next period of 4 or 5 years. After a prioritization exercise, the oceanage industry and research professionals agreed that the design and validation of oceanage devices is the most urgent and crucial area to focus on. However, there are other challenge areas aimed to support this one, including foundation, connection, that is the topic for today, mooring, logistics, marine operation, integration in the system, or data collection. A similar prioritization exercise was conducted for the identification of a number of priority topics per challenge area, according to the opportunity for the sector in Europe and the urgency to be overcome. For each priority topic, the SRA defines its scope, applicability, specific actions to be carried out, expected impact of deploying these actions, the technology maturity at the start and end of the projects, and the budget required, giving indication of number and size of projects. The webinar today deals with foundation, connection, and mooring, more in particular to connections. The challenge area on foundation, connection, and mooring includes 2 priority topics, one for floating devices and the other one more focused on bottom fixed devices. Both propose to develop bespoke solutions, taking into account high demanded site conditions. Suggested actions include, for example, the development of combined solutions for electrical and mooring connection, or the use of innovative materials, among others. In both cases, the expected impact is the contribution to LCOE reduction by reducing CAPEX, OPEX, while increasing availability. Thank you very much for your attention. Let's now learn from practical experience of 3 interesting examples of innovation in connection systems.
Thank you, José Luis. Indeed, we will start with the 3 presentations. So we'll have 10 minutes for each presentation and time for Q&A. So if you have any questions at any time, please write them in the Q&A box on the right side of your screen, and we will take them then after the presentations. And with that, I would like to give the floor to our first speaker, Yvonne Larrea, who is the Chief Technology Officer at ITREL. So with that, the floor is yours, Yvonne. We can see your screen. You can just go to full screen mode. It should be at the bottom of your screen.
Yeah, thank you. Sorry, I couldn't find the unmute. So thank you, Lotta, for the introduction. Good morning, everyone. And thank you, ATIP Ocean, for the invitation, and to the audience for the interest and for the time. My presentation is divided in 4 parts. The first slide is about the company, ITREL. 3 slides about the connector, the electrical connector, conectados. 4 slides about collaboration projects, and 1 slide for the next steps. ITREL, we're a small company, just 6 people working since 1983, manufacturing steel products. We combine cold forging processes, hot forging, basic welding processes, hot dip galvanizing, to provide bolts for the electric onshore market, as you can see in the final picture in the circle, bolts for the glass insulators, but for the onshore market. All those activities in the factory located in Vitoria-Gasteiz in the Basque Country. This is the picture of the factory. This market is too mature for us. That's why in 2013 we decided to diversify our range of products And we made one alliance with Tecnalia Research and Innovation, which is the first institution regarding research and development projects in Spain. They had one idea to reduce the cost of the electrical connections for marine renewable energies. And we had the need of diversification and the private strength to take this project on. And that's why in 2013, the new project was born, the Conectados project. And just to give you a brief overview on the typical picture when we are talking about subsea electrical connections. This picture is courtesy of Smart Bay Island. And we have, as in most cases, the sport cable in red that comes from the shore, the static connector that relies on the seabed, and many marine energy devices. We have two options when we want to connect to the static cable. When we take our device with the dynamic cable, we can connect under the water with wet-made connectors to plug in wet conditions with water pressures. On the other hand, we can raise up this static connector with a crane and plug the dynamic cable in dry conditions with dry-made connectors. More complex maneuver, but cheaper connectors. Then once connection is done, the static connector and the rest of the dynamic cables will be placed again on the seabed. In our case, in Conectados is a mixture of concepts. The concept of connection consists on two bodies. One male connector that is pre-installed on the dynamic cable. So the dynamic cable is put to the length, peeled, electrically terminated and tested onshore. On the other hand, we have the housing or the female part that is welded or attached to the floating converter and is watertight, so it's prepared for underwater connections. The housing is provided with an elevation winch for the maneuver, for the lifting maneuver. And this maneuver can be performed from the sea level or from the wake level and allows wide water windows and avoids big vessels with cranes. You have the sketch on the top part with the male part and the housing with a mechanical coupling between both of them, and then to have access to the electrical cables from the dry conditions of the wake. And on the bottom part, the real pictures of the full-scale prototype for 20 kV, the male part and the housing with the winch on the top. This connector is ready for power, for optical fibers, for auxiliary supply. The design is specific for marine renewable energies and is suitable for other off-the-shelf cable protection systems like bend stiffeners. The design is suitable specifically for floating devices, although it could be also useful for other non-floating devices. And the voltage level goes from 1 kV to 66. The solution is patented, was validated in BMEP, which is the offshore test site that we have in the Basque Country. We obtained one approval in principle certificate, and now we are running the type approval certification with Bureau Veritas as well. As you can see in the picture, the certification gained in 2017. The reliability of the connector, which is a topic for today. We have performed several watertight tests for the male part by using pressure tanks for the male part here, for the case of the connector, of the male connector, for the mechanical coupling between male and housing, for the housing itself. We have performed lab tests for mechanical purposes with tensile test machine, axial loads, but also dynamic loads by using cranes and loads. In this picture, in the bottom picture, we have the clamp that attaches the cable to the structure, to the connector, because this is the most critical part. And we can see after the trials, the aspect is a good aspect. We also have performed survival tests in BMEP, as said before, to test the logistics by means of a humble tugboat and inflatable boat, but also for survival trials, putting the connector on the seabed and at minus 15 meters depth in different conditions, just to validate the survivability. Then moving to the relevant collaboration projects, the first one, the RECODE project, one European project, together with other 6 organizations. Each organization to develop one cost-effective device. In our case, the connector for 20 kilovolts, as you can see the picture, but other devices like wave measurement buoys, safety monitoring devices, dynamic cable monitoring systems. Another collaboration project from last year, the SEMC project, it is a call from Wave Energy Scotland for quick connection solutions. We developed through stage one combination between our electrical conectados and 3 mooring lines. You have the picture here. We developed from a theoretical point of view only during stage 1, working together detailed with 4C Engineering and Tecnalia as well. We will probably continue developing this combined solution in the next months. And then collaboration projects with end user, which are the top project for us. The Triton Sea WEC from Mozilla Power is well, a floating device, and we downscale the connector from 20 to 1 kilovolt. We manufacture the connector and provide it to Stilla Power, and now we are giving support for the grid connection at 1 kV. This device will be connected in the test site in Hawaii this year. And some highlights, it's vital, the total transparency and information exchange with the client to exchange 3D models and the weak points of each device to know all the potential failures. To be flexible to the client needs in terms of time, cost, and support. As you can see at the top, the conversations began in 2017, so a lot of years for this issue. And of course, given on-site support and all our potential services, not only the product. And as well, flexible from the technical point of view for the connector to make it suitable for different configurations, like different dynamic cables, steel armored or synthetic armored, different cable protection solutions, different sizes of bend stiffeners, and even different angles of connection. We can see at the left picture that the floater with the dynamic cable. This is in the middle picture, the request of the client to make the connection at 45 degrees. So placing the housing at 45 degrees, and this is the real picture of the housing inside the WEC, making it possible. Another project is the Blue Growth Farm. It's an H2020 project, European project, where we designed and are validating the connection to the grid of one multi-purpose platform that combines wave energy conversion with floating offshore wind and aquaculture. The connection is to be done in 1 or 2 weeks in Reggio Calabria in the Natural Ocean Engineering Laboratory this month. So you will have news in the next future. We learn to integrate with different structures, like concrete structures, and the prototype will be connected at 1 kV, as in the previous case. But for the full scale, we are considering up to 66 kV of voltage for the cable. This is the housing, again, with the winch inside and the male part attached to the cable. And the third project is the X1 project, X1 Wind project, where we designed, manufactured, and have supplied one connector for 20 kilovolt for this floating offshore wind platform. The connection is to be done in Plocan, in the Canary Island, this month as well. So a lot of activity for the incoming weeks. Again, proactivity with the client because we have the know-how of the connection, and we must put all our knowledge on the hands, and to make the connection possible in this corner of the platform, because this is a particular pivoting buoy, so a rotatory connection is performed here, and we have made it possible. And we have made possible that the male connector to be installed on the deck of a vessel instead of inside the onshore conditions that we mentioned at the beginning. So it's a quick installation. We have the picture of the platform. We have the 3D model of the male connector, a long male part with 1 meter long to adapt to the client requirements. This is the real connector, the steel parts. And the right picture is the clamp where the cable attaches to the male part, the most critical part. And the final slide, the next steps for this year to finish the 4 on-site grid connections, the 3 mentioned before, plus another one that we are making progresses, to finish the type approval certification with Bureau Veritas and gain more reliability, to be more reliable for the market, and to start developing the remote maneuver, because up to date is not remote, but we want to avoid people on board the WECs or the floating platforms, to integrate and to further develop the integration with the mooring lines by means of a single point mooring. And finally, to start by the end of this year, developing the digital twin for the connector to make it easier, the operation of the future wave farms or floating tidal farms or oceanic farms. And that's all. Again, thank you for your attention. And you have my email, and I'm ready to answer any question.
Thank you very much, Eben. We'll be happy to hear those news from that Calabria connection in the next weeks, hopefully. I suggest that we continue with the next presentation. If other panelists have any questions for Eben, please note them down and we can take them after all the presentations. So I am handing it over to Gavin McPherson, who is the Head of Research and Policy at Nova Innovation. So the floor is yours, Gavin.
Thank you, Lotta. I'm just going to share my content.
Mm-hmm.
Can you see that now?
Yes, perfect.
Great. So thank you, Lotta, and hello to everyone. As Lotta says, I'm Gavin McPherson from Nova Innovation. We are a tidal energy device and project developer, so we do everything from designing the devices to building them, to deploying and operating them, decommissioning, and we also develop and operate tidal energy projects. We were founded in 2010, and we now employ over 30 people across the UK and in North America. In 2016, we deployed the world's first offshore tidal array in the Blue Mill Sound in Shetland. I'm going to show you a picture of that now. So can you see it? Nope, can't. There's 4 turbines there, honestly, but they're all subsea. They're deployed at a minimum charted depth of 15 meters, and so our device is entirely subsea, and obviously, so we need subsea connectors to connect them to shore. The first devices were deployed in 2016 and 2017, and the 4th device was deployed just last year. I'll show you some photos of those. So there are 3 Nova M100 turbines that you can see on the left there at the device, those at the array. Those were deployed in 2016, 2017. You can see the turbine architecture there. It's a 2-bladed horizontal axis turbine. There's no yaw pitch mechanism. We find the cheapest and most reliable components you can get are the ones you don't need to buy. So to maximize reliability, we've minimized the number of offshore components. That device has a geared drivetrain and it uses a dry mate connector. The device we deployed in autumn last year is a direct drive variant of this device. It's but otherwise very similar design, but it uses a wet mate connector. So we've used both dry and wet mate connectors at the site. The technology now is very well proven. We've had over 36,000 hours generating to the Shetland grid. And And we've learned a lot in that time, what I wanted to share with you today. So you can see a little bit more about the full experience you've got, from working pairside to deploy, to build devices, to deploying them offshore. I'm going to show some video there of an actual turbine spinning subsea, as they've been doing now for over 5 years. And you can see the control panel on the top right, so we can control the devices from a control room in Edinburgh, from anywhere in the world. We've also, you see a Tesla battery bottom right, we've installed Tesla battery storage at the site, so we can provide flexible dispatchable power to the grid. And we've also got a car charger just recently deployed, so they're now tidal powered cars driving around in Shetland. I wanted to show as well the video at the top there. You can now see of what the conditions can be like. It's a fantastic site, it's really well sheltered. 30 minutes before this video was taken, it was flat calm. And then, you know, in 30 minutes, the weather can pick up and you've got to deal with this. So that's the point. One of the main points I want to make is that when you're working offshore, the conditions can be unpredictable and can be very challenging, and so you need a very robust solution. So in terms of experience with connectors, they have been our most troublesome component by far in terms of the time and the cost of finding problems with connectors and fixing problems with connectors, an order of magnitude more troublesome than any other component we've had. We tried turnkey solutions from major manufacturers. All of them have failed. Some lasted a few months, others a whole lot less. And we believe that, we know that almost all leading marine energy developers had similar experience. And I think the reason is the existing solutions are fantastic for the applications they've been designed for, but they're not designed or suitable for the highly energetic, bioactive, highly oxygenated environment you get in marine energy sites. As well, not just our environment, but the way we operate the connectors are quite different from a typical subsea connection, say deep water subsea, where you connect and forget. You put something in deep water and it's there for 20 years and you only connect it once and disconnect it once. Whereas for our devices, particularly in the demonstration phase, we're putting them in, taking them out again. So we're seeing lots of connect and disconnect operations. And also the loads experienced and the working conditions on the site are really, really difficult to model, especially if you've not been out on site before, when you're just developing a device for the first time. There are tools available to help you with this, software modeling, there's lab tests, there's test types, and they're all valuable, but there's absolutely no experience for in-sea operation. And so we've learned a lot from that. And so we developed a solution which is called NovaCan. It's really a system of subsea connectors designed for marine energy. So our NovaCan solution provides power, auxiliary power, and communications. It comes in 3 different parts, which we've all demonstrated and developed to demonstrate in the Horizon 2020 ONFIT project. There's a cable termination, there's a dry mate part, and there's a wet mate part. I'm going to show you slides on each of those. It's been designed for tidal energy at a particular scale, but it's very scalable, and it can be applied to other tidal devices or to wave energy devices. It can be integrated into the device itself or into a mooring connector, or as a standalone cable-to-cable connector as well. I mentioned it's scalable in terms of power and voltage. We've also, in terms of communications, we can use copper or fibre, and both of them have been demonstrated at the site in Shetland. It's got a really robust cable termination, which is very important. As far as possible, we use off-shelf components. They're very reliable and cost-effective, and we try and minimise the time it takes to make a connection and actually operate on site. So first, I'm going to talk about the cable termination. So that's the interface between the cable and the connector. We need something really robust that can take mechanical strains and provides water blocking as well. So we designed something based on experience in Shetland, which is now deployed on all 4 of our turbines at the sites. It's been deployed. It's been 100% reliable for multiple device retrieval and recovery operations, and many years now of successful in-sea operation. This component in particular, for all that are really highly transferable to other marine energy applications. So that's the cable side. Then on the device side, you can have a dry mate or a wet mate connector. So we tested both of them. You can see the dry mate connection solution here on our earlier M100 model. It's on the right hand side. I've got a zoomed in picture there on the right. So the cable termination is at the point where the cable comes in, and the dry mate connector is the bit that connects to the device. That's been successfully deployed now in all 3 of our M100 turbines, and again 100% reliable. It's been operating now for many years. But we went for dry mates originally because we had an earlier device, which I'm not showing here, 30 kilowatt one. And we looked at dry mate and wet mate connectors, and we asked for a wet mate solution for that. And the quotes we were getting back cost more than the rest of the device put together. It was just a bit nuts at the time. I don't think the market is quite the same now. But so we had to go with dry mate at that stage, and we stuck with it for the M100. But dry mates are really troublesome. I mean, you've got to recover a cable with the device. You've got to handle the cable on the boat. It's difficult. It's time consuming. It's expensive. It's risky. You really don't want to be doing that if you can avoid it. Now, dry mate is fine for certain applications, but for our devices, wet mate makes much more sense. So in the new direct drive device, the 4th turbine deployed at the Ray, we've got a wet mate solution. So you can see the cable you can see the wet mate there, which is the orange part on the device. The cable terminations at the bottom connecting to the cable, and the wet mate connector is the part above that. That was successfully deployed on the 4th turbine in the Ray, and as I say, it's been operating absolutely fine since then. But again, suitable for a variety of web applications. We've been developing a next generation model of the wet mate part under the WES quick connection system. I can't give much more detail on that just now, but there's ways for this. This has been a very robust and reliable solution, but there are ways for it to improve in the future. So just to summarise, we're looking for something which gives electrical and communications connection for marine engine devices. We developed dry and wet mate solutions. It's proven 100% reliable for multiple years and multiple mate and demate operations. We're really keen to share the experience that we've had in this with the subsea connectors, for mutual benefit with other projects and device developers. So if you're interested, please get in touch. And thank you, Lotta. Back to you.
Thank you, Gary, for the presentation. Wait, I will just keep the presenter as Richard. So I will run to the next presentation. Voilà. We have Richard Jem from Quotient, who will talk about their solution for the connectors. I believe you should be able to share your screen now.
Yeah.
Yeah.
Okay, has that come through okay?
We do not see your screen yet, but we can hear you.
Okay, hang on. Let's just check.
Yep, it's coming through.
Okay, I see all the garbage of the day.
So now we can not see your presentation, but your screen.
Computer's decided to go into. Right, here we go. We're getting there.
Yeah.
Okay.
Perfect.
We're good. Okay, so thank you for the opportunity to speak at this webinar. Just to
sorry, Richard, if you could just minimize the webinar screen, because we can see ourselves. Maybe put it on the side. Yeah, that's good. Thank you. Yep.
There we go. Is that better? So yeah, thanks again for the opportunity to speak at this event. I think it's very topical and important for the sector. Just very quickly, a first introduction to Quotient. For those of you who don't know us, we're the core technical team from Polaris Wave Power. Obviously, very extensive experience in earlier phase of the industry, but still very relevant today. We cover all the disciplines from fundamental modeling all the way through to deployment and economics, cost of energy, and very much bringing, and there are a number of us in the sector who are doing this now, bringing the practitioner's perspective with a sort of whole system approach. So understanding all parts of the system, the environment, and its deployment and the economics, so we can give a sort of genuine shortcut to the industry, so you don't have to relearn what we learned in the Polaris program. We've had very exciting 6 years, over 6 years now, with a broad range of clients, but we're also advancing a number of the core technologies from within Polaris, which actually are highly relevant to the sector. We've been developing the power takeoff systems we had for Polaris. We've been looking at how to bring fatigue optimized structures and how that interrelates to the codes to the sector, and then obviously relevant to this presentation, quick connection and disconnection systems. And if you want to get in touch, we've been working with quite a few of you anyway in the sector, but just drop us an email and we can talk about how we can help you. So, sorry, I'm just having some issues with my computer. Here we go. So, quick connection system benefits. I think we've had a couple of slides of that already, but I think the sort of summary for the sector and the takeaway, and I think the sector was slow to pick up on this as an enabler for the industry. I think it's all about facilitating safe execution of big jobs with much more modest vessels than the sector has been using to date on a year-round basis and in tough conditions. I mean, the plot in the top left says it all. You can peruse it after the event, but it's a plot which has the average time that you would wait for a weather window for various wave heights at different times of year. And if you look at these statistics, it shows that you need to be able to operate in conditions of 2 meters significant wave height or more and 20 knots of wind or more with your connection system if you're not going to be waiting a disproportionate and uneconomic length of time in order to complete your operation. The machine gun plot on the top right is from our Polamis system across the 6 machines that we deployed. For installs and removes, again, you can look at that in your own time, but we had over 50 install remove cycles successfully executed in up to 2.5 meters significant wave height. And that's really the enabling step for the technology. For prototypes, particularly important because it allows us to use, or at least get close to using the ocean as a wave tank. We all know and understand that the risks at the prototyping and initial scale-up stage are much higher, and the ability to recover your machine quickly to inspect or repair is absolutely crucial. And indeed, there have been a number of minor problems in the sector which have led to major or catastrophic events that could have been avoided if there was a quick connector-disconnector system. I think that people do look at the capex of these systems, and they can bulk, but it's very easy to demonstrate that the capex is absolutely eclipsed by the ongoing OPEX savings through even just a few installs. And I'll come back to that. And then longer term, and I think this is important for investors as well, it enables an off-site maintenance strategy, certainly for floating machines, where you're actually bringing the machine in for inspection and repair rather than trying to conduct that operation offshore. And I'm reminded of a phrase that I heard many years ago, which is a job that costs €1 on in a factory will cost €10 on the surface of the sea and €100 on the seabed. And this is really about bringing the system to the equipment rather than the equipment to the site, and huge savings in terms of commercial projects going forward. So just looking at the quick connection experience that we have, I think we're quite unique in the sector for this sort of system. We obviously built the original Polamis. The 3-letter acronym was TLA. It was the tether latch assembly for the Polamis machine. And there's a picture there of it during connection, actually up in Orkney, that one. We could achieve with a modest multi-cat vessel an installation in under an hour and a removal in under 15 minutes. And indeed, we had to remove under pressure a couple of times when we had issues with the machines, and it was fantastic to be able to just drive out, pick up a floating line, and tow the machine through Bournemouth or back to Porto in very short order. And as I said before, we completed 50 cycles of installation up to about 2.5 meters each. I think it was 2.75 for one removal. And we've actually documented a lot of this, and I think it's a resource that some of you may well not know about. But if you go and register at the Wave Energy Scotland Knowledge Library, you can download a series of reports on this, which detail the design, the experience we had, and the learning that we've been able to carry forward into the systems we're developing now. One of our early projects was there was an urgent need to come up with a solution for the cable termination for the Andritz turbines on the Mayjohn project. There were no wetmates involved. It was about bringing the static cable, which was like copper bars, into the nacelle, and we only had a couple of tons as a budget, but we managed to come up with a solution for them that has worked successfully. It's had a few issues, I believe, but it got the project operating. And then recently, just last year, we worked with Inyanga Maritime to deliver a bottom joint system for the Modesto DG100 system up in the Faroes, and that was from that design all the way through managing the build and then assisting with installation up in the Faroes. And there's a picture on the top right of the unit being plugged in at the bottom of the Faroese fjord. We've also, that's the practical projects, but we've also completed a large number of feasibility and integration studies with a number of you in the industry, and that's obviously provided a lot of context for the project that we're working on now. So when Wave Energy Scotland came up with the QCS call, we very much very keen to be involved to create a sort of generic solution out of all these different projects that we've been involved with, which gives a combined mooring electrical system, which we think is important. So we have a sort of one-point connection that gives us this operability limit. So it's self-installing. There are no people on the WECs or involved directly in the operation. But we wanted to make it modular, so it would be able to be configured in a pull-up, a pull-down, a pull-through, and in fact any other configuration required by the industry, so that it was as applicable to as many systems as possible. We deemed that it needed to be self-latching, but command release. We mustn't involve divers or ROVs in the operation. And then absolutely critical, it's actually interesting what Gavin said before, the wetmates need to be, in this sort of dynamic application, need to be mechanically isolated. So we have an independent compliant carriage, which effectively transfers the reference of the wetmate connectors to the same frame, so that they're not involved in any mechanical motion or deflection. And I think a lot of the problems people have had with connectors in the sector is because they haven't had this mechanical isolation. So this system is being actively developed. We have a range of different solutions, all based on the same configuration for up to 600 tons of mooring load. The wetmate connectors we're using are actually the ones we've had very positive experience through from Polaris, which are Gizmo 6.6 kilovolts. They are good for about 1.25 megawatts. And we have an auxiliary power connector, which has got fiber comms in it as well. So it's a sort of standard connector package, but of course it is applicable to any other connectors that are available. The program is all about creating pre-qualified and then certified components. So there is a minimum of application-specific work. It's about mechanical structural integration of the female receptacle into the WEC or tidal energy converter, and not about actually designing all of the different elements of the system within it. And the objective, which so far the modelling has very much underpinned, is to pay for itself within 2 install-remove operations. So fair amount of capex, but easy to demonstrate that pays for itself very quickly in an operational program. So just to conclude, the technology has been taken forward in a Wave Energy Scotland funded project. We've completed stages 1 and 2 successfully so far, and we're at the stage where the feed work is completed, so everything from structural loading to integration of the components into a WEC, the actuation system, the control modes that it will operate in is all completed. We've looked at a couple of case studies with some prominent WEC developers and actually considered more detailed integration into them for 2 configurations, and all the way through to costing and operational support. We're currently intensively working on the stage 3 bid to continue the work, and very much hope we can continue to be supported by Wave Energy Scotland, which will move to build and qualify the system in a relevant environment is the spec. But in parallel, we're very much looking for the first users of this system. Obviously, its heritage is very long, but this system needs some guinea pigs, for want of a better expression. And so we're actively searching for those at the moment. So if you're interested, then please do get in touch. And we're looking to have the system ready for first deployments in 2023 2024. And sorry, I should have said the partners on that project, obviously funded by Wind Energy Scotland and Yangamar Marine Projects, very much involved. EMEC, very much bringing the test centre perspective and a broad range of experience of different approaches, and SMD, who are a major subsea provider and ROV manufacturer. So that's the summary of the system. Thank you very much for listening, and obviously delighted to take questions, but please get in touch if this is of interest.
Thank you very much, Richard. Thank you for the presentation. I stopped your screen sharing, and I would like to invite all the panelists come on stage. We have now time for a Q&A, so while the audience types their questions, we have some questions coming in already. I would like to just check with the panelists if they have any thoughts or questions regarding each other's presentations. Feel free to raise your hand or unmute yourself. Iban, you go first.
I can start with the first one. Very interesting, all presentations. But regarding the NovaCan, I would like to ask Gavin, could you give us an overview of the cost effectivity or between the wet mates and the dry mates, considering the testing period for array configuration? So in terms of cost, what kind of connector will you suggest for each kind of configuration? A small offshore test or pre-commercial array?
I think there's probably sufficient difference between the different technologies and even the sites that they're deploying on. You probably need to consider it on a case-by-case basis. But I think one of the just really the important points to make, which Richard made much better than I did, so I'm going to echo some of what he said, which is that it costs something that costs a certain amount onshore, costs 10 times more on the surface and 100 times more subsea, and the lifetime cost of a cheap component can dwarf the initial capital cost. That's absolutely been our experience. That you might save a bit of money, you might try and squeeze down the cost of, say, a subsea connector, but if you get something which is a bit less reliable, you wipe out any cost savings within one failure, or even potentially you can get something that's cheaper, but it's much more difficult to actually make and release the connection. It doesn't do things so quickly, and you burn up that cost in the time that it takes to actually wait for a suitable sea state to make that connection as well. So I don't think I can make we went for dry mate connections originally because they were so much cheaper. Now I think the wet mate connections aren't, well, we've demonstrated ourselves, wet mate connections are no longer like an order of magnitude more expensive. But there are different considerations for different technologies, and to whether you're floating or subsea or in the middle of the water column as well. So I don't think there's one solution for all. But certainly from our point of view, we're moving more towards wet mate connections. So you can just connect them once, you deploy with the device, it all happens very quickly, and then you can just forget about it.
Thank you, Ivan. Actually, I wanted to ask something regarding that. I mean, we heard from Richard and Gavin now that they're moving towards the wet mate connectors, and I was wondering whether what your take is on that. Do you think the wet mate is the way to go, or does it really depend on the use or the technology?
Well, quite. I mean, we've used wet mates right from the start in Palamis, and I really do think they are the way to go, and the cost will converge. They're still quite specialist products. They're basically made for oil and gas and for submarines and so on, rather than any kind of volume application. But the costs are converging, and I think by the time you have a sealed system for and a carriage system for a dry mate, the costs are probably not dissimilar. I think it's about as an industry, trying to pick connectors and trying to achieve some sort of scale, some sort of standardization, so that we can actually get an initial volume into the suppliers.
Thank you. Ivan, do you want to comment on that before we move on to the next question?
No, I agree. It depends on the case. Even for the 3 clients we have, each case is different. We should analyze which is the best solution for each one.
Thank you. I'm going to look at the questions from the audience now. I think we have a first one for Gavin. Regarding Nova Innovation, how would you find procuring subsea MV cables for relatively low power output system, such as the 30 kilowatt system you mentioned? From what I've seen, the umbilical costs do not increase linearly with copper cross section, meaning lower power systems have a very high cable cost per kilowatt hour. Gavin, if you could please.
Yes, yeah, that might be a little bit technical to have a full question here. I hold my hands up. I'm a physicist, a lapsed physicist, not an engineer. But I think there's a couple.
Let's try.
There's a couple of principles I can bring out here.
Yeah.
One of them is that if you're just looking to say deploy one small device, then often there's bits of cable about. Then you can take two. You don't have to kind of make a piece of cable just for that device. There are often pieces of offcuts from things that other people have done. You know, I think if you're just at the early stage of developing a project, you have to try and find cost-effective components. And so despite the fact it might cost quite a lot, if you buy it from an assembly line, many people are throwing away bits of cable, which you can use perfectly well for your system, so you can save money that way. And I think another point to make as well is that there are economies of scale of these things, like 30 kilowatts. You will get economies of scale where you go from 30 kilowatt to 300 kilowatt to 3 megawatts, certainly. But if you're just starting out early, if you put all your money into developing like a 3 megawatt device, then you miss out on this invaluable experience you get from actually going to the sea and testing something at a smaller scale. Like Richard said, we have the kind of order of magnitude difference as you go from onshore to offshore to subsea. It's the same as you go from a bench test to a test tank to an actual in-sea testing. You learn about it is order of magnitude more that you learn there, and that knowledge feeds back into the design, which you can do all that at a much smaller scale and a smaller capital cost, and learn from the small scale projects, and then that knowledge feeds into the larger scale in the future. That's been very much Nova's philosophy.
Thank you. The next one is for all the panelists. What do you see as the next major challenges for the development of connectors to meet the future demands of the offshore renewables or ocean energy sector? I'll let Richard maybe answer this one first and then go to Yvonne and Gavin. What are the next major challenges?
I think clear is the available maximum voltage on integrated power connectors. I think comms and fiber connectors are now very much available and proven, but the main set of integrated connectors where you have all of the power terminations, all the pins in one nice package rather than individual poles, do generally limit it to around about 6.6 kV at the moment. There are plenty of designs and there are some prototypes for 11 kV. And I think that's very important for the industry, that it moves to a nice compact, similar to the Gizmo connectors, RMS punctuals connectors that can take us up into 2, 3, 4, 5 megawatts. And the key to that will be raising the connection voltage.
Thank you. I'll let Yvonne continue from there.
Yeah. Thank you for the question. One challenging issue is that there are not many dynamic cable manufacturers, and in the end they are the client for us, as we are one auxiliary device for the cable, so we need to pass through the cable manufacturers acceptance, and there are not many, as I said. And another challenge is that we need to see floating devices connected to the grid to perform real trials with them. In the meantime, we have some of them, but very few cases. We can further develop our connectors in real offshore conditions with the floating offshore wind, which is similar to the oceanic energy, but there is a wider field to investigate and to try in offshore real conditions our connectors in the meantime.
Great, thank you. And the next big challenges, according to Gavin.
Yeah, I think probably I agree with everything that's been said, but it's also just taking a higher level view, just proven connectors. I mean, I look forward to the day when we don't have seminars like this because connectors are boring again. And I think we're getting there. I think when we first designed our devices, and when many people do, you're focused on the device and you think the connector, that should be easy. People have been doing that for years. And then you find out that it's not, and everyone's going to learn that lesson now. And now that experience, a part of the reason was that we went to major suppliers and we thought we could benefit from their experience, but their experience does not cover working in the kind of conditions that we work in. And so that experience now has been gained by people like the people on this call. And so what I'm hoping is that anyone who's looking at developing future devices or projects, they can build on that experience. And so give people like ourselves and others on this call a ring, and they can benefit from that experience. And I really hope to make connectors boring again.
Great, that's a good answer. Thanks, Kevin. We have time for a couple more questions. So regarding the transition of connectors from oil and gas to the renewable sector, have the international standards been developed for which all connectors must be qualified to, or are they still being agreed and developed? I'm not so sure who I should ask to answer this question.
I'm happy to sort of chip in. I'm afraid I can't rattle off the number of the code and standard used, but all of the wet-made connectors that we can choose in the sector are qualified to a common standard. Maybe somebody can jump in and help me there. I think the key thing is to try and look at that. At the moment, we're only able to looking at 1s and 2s of connectors, so we're not able to get the manufacturers to undertake a specific qualification for our kind of application. And I think that's really, again, where the benefit of standardizing, if we can all start working with the same equipment, we can gain traction with the likes of Gizmo, Deutsch, RMS Pump Tools, Spectron, Siemens, sorry, and actually start getting that reduced product with the kind of performance we need. But I think it is worth saying, just quickly following on from the previous answers, is that we've had a very positive experience with the connectors we've used, but it's about making sure that they're applied in the right way. And I think there's been lots of mistakes made in the industry by not mechanically isolating the connector from any motions in the connection system itself, and that's absolutely crucial. So I think the kit is good, it's too expensive, but I think it does have a pathway for the sector to an economic solution.
Thank you. Did you want to say something, Kevin? Go ahead.
Yes, yeah, just chip in on that as well. But the standards, I guess when we talk about connectors, there's the pins themselves, which are embedded in the connector system, and they're kind of available off shelf and well proven. The standards for those, but really, but then eventually have to build a whole system around about that, which often involves a degree of bespoke design. And there are standards available for that for offshore engineering, and I can't rattle off the numbers either. But really, this application of these standards is new. And at some point, I suppose the experience we're gaining from developing these systems might be baked into future standards. There are standards. There's the ways to. We've got the standards give you a way to approach it, but I don't think they don't automatically result in reliable connectors. And so I'm hoping standards eventually will be updated to reflect the experience we've had working, particularly for marine energy devices, and we'll see something more tailored to it. But that really is it's going to be based on experience.
Great, thank you. I'll take one last question, which is not actually about connectors, but about the future of the whole ocean energy sector. So we have a question from an engineer student, and she's asking what steps a student should take in order to end up working in this sector. I'm sure we're always ready to welcome new talents. So I don't know, Kevin, do you want to continue that? Are you looking for interns or?
I think I'm not sure where she's getting in touch from. That might be quite.
It doesn't say.
No, this is the kind of thing. There might be different recommendations depending where you are and where you're trying to go. But really, the advice I make is that there are things happening in the sector. There are things really happening where we're building devices and getting them actually operating them in the sea. We talked a lot about that today. I think the closer you can get to that, the better. I can't give specific advice about where to go to for that. But to either speak to maybe if you're developing your career, speak to academics who are working on these projects and therefore get some experience in those projects, but try and kind of get direct experience from the machines which are going in and operating in sea. I think that's the way I'd recommend, because the sector's going to grow from there.
Excellent.
There are schemes. Obviously, there's ID Core. I don't know what stage the lady is at, but there are a number of funded and routes into the sector. But I think certainly stood all of our team well instead when they originally joined us at Palamis, and obviously the people we've recruited since, is just get in touch. Just, you know, if you're showing enthusiasm and interest, then you just have to hunt out the opportunities yourself. And I think that initiative will be rewarded.
Thank you. Yes, and I was going to say that a lot of universities are also involved with ocean energy projects, research and innovation projects. I don't know, Ibon, if you want to add on that.
Just one last idea in the meantime, until you have the opportunity to take part in or to have contact with the real projects, there are specific marine masters or degrees from 1 year or 2 years, just to continue getting closer to that field, to the offshore energy, because it's very, very particular, and just to continue obtaining knowledge on this from the available masters and degrees.
Great, thank you. I think we will close our webinar with that. So just being active and getting in touch, I guess. Well, thank you all the panelists and the audience for your questions. I can already tell you that the next webinar will be on installation in mid-June. And if you're on the Egypt Ocean mailing list, you will receive a direct invitation. So you can register. If not, you can join the mailing list on our website, egyptocean.eu, and join us. And yes, I would like to thank you again. Wish you a very nice rest of the day, and see you in the next webinar.
Thank you very much.
Bye-bye. Thank you all.
Thank you. Bye-bye.